the other graduation speech. It was a botany bar. And I remember Amanda and Shane skipping along, singing songs to each other. I remember Zaya excitedly, enthusiastically telling Morgan about things. Claudia wasn't with us that then, but I can imagine her naming all the cute animals she found and telling Nilla all about it. And Nilla occasionally looking amused, delighted, confused, or exasperated by that. Halfway through the walk, we found a rock that was taller than my head, probably taller than where the top of the mic is. And the boys asked Mr. O'Binen, can we jump off that? This group's been fun to work with because they're rambunctious, but they're very politely rambunctious. They ask before they do things. Mr. O'Binen, can I rappel off the balcony? Okay, I'll continue that after Willy Barnes' presentation.
For my graduation project, I decided I wanted to do something that combined both science and building. I was aware of Friends plasma cars, which are a ride-on toy car that is propelled by moving the steering back and forth, and was curious about how they worked. I decided for my graduation project that I would try to build one and learn the physics of how they worked. I started designing the car using a computer drafting program to create a 3D model, and then I made some wooden prototypes. Then I decided to use 1-inch square tubular steel, a steering column cut from a bike, and caster wheels to build the car. To make precision cuts in the steel, I went to my neighbor Neil Hochstetler's machine shop. He allowed me to use his cutting tools. This winter, I took a course at Riverbend Technical School in welding, enabling me to weld the frame. I completed the frame and assembled the car and did some tests. It worked well, so I took it apart, did some touch-up grinding, primed and painted the car, and then built the seat, and the car was done. By experimenting with the car, I learned that the car moves because of friction between the wheels and the ground. To understand how the car moves, we need to understand some simple forces. Here we have a ball on a platform. There's two forces acting on the ball. There's the force of gravity and what physicists call the normal force, which is the force of the platform on the ball. The normal force is always perpendicular to the surface. Now, these forces are equal and opposite, so they cancel each other, and there's no net force. Now, if we take the ball and put it on the slope, we still have the force of gravity and the normal force perpendicular to the surface. Now, these two forces are not equal and opposite, so they do not cancel each other, and so there is a net force in this direction. Now let's talk about some forces that run horizontally. When I use my muscles and push on the table pushes on a force on me, which is called the normal force. Since the only force that's pushing on me is the normal force of the table, the forces are not equal or opposite, so they do not cancel, and I move backwards. Now, let me put my feet on the floor. The same thing happens. I exert a force on the floor with my feet, and through friction, the floor exerts a force on me. And the forces do not cancel, so I move backwards. Now, let me show you my car. Okay, so this is my car. I picked up the front so we can look at the wheels. The car works by pulling the handlebars, which move the wheels in towards the center line. We'll call this position the neutral position. If the car were to roll, it would roll straight forward. Now, when I pull here, well, I'll start with the handlebars and the wheels at a 90-degree angle. If I was to pull on the handlebars, we would have the force of my muscles in this direction and the force of friction in this direction. And just like with the chair, these two forces, the only force that's affecting the car is the force of friction. So the car moves forward. Now we can do the same thing, only at a 45-degree angle. The same thing happens. The only force that affects the car is the force of friction, therefore the forces are not equal or opposite, so they do not cancel, and there's a net force in this to up, straight, and to the right. The car moves straight and to the right. In doing this project, I learned about forces, and I learned that the car moves by friction in between the wheels and the ground. If I were to make changes to the car, I would think about maybe making these wheels wider, or making this arm longer, or even making the front and rear wheels turn. I wonder if that would make the car move like a snake.